Howdy. 21 hours ago, on phys.org, a searching glow in a distant galaxy could change the way we look at black holes. Yeah, maybe it's worth to think about that. Did you really ever watch a black hole? Are there really black holes out there? I tried to explain my 6-year-old daughter a few weeks back when there was the news about they have been found 75,000 bright black holes. And I tried to explain her that, it's a black hole and it's really bright. And she looked at me and said that, but Dad, either it's black or it's bright, but it can't be both at the same time. That it doesn't work. So, and then she was saying that, isn't it a spark which is happening? A lightning bolt? And I was thinking that, yeah, she may have listened once when I tried to explain her some things. At the plasma rock site, for example. But let's go over this quickly. Something strange is afoot in the galaxy known as 1ES1927 plus 645 in late 2017. And for reasons that scientists couldn't explain, the supermassive black hole sitting at the heart of this galaxy underwent a massive identity crisis. Over a span of months, the already bright object, which is so luminous that it belongs to a class of black holes known as active galactic nuclei. Let's read that again. Which is so luminous that it belongs to a class of black holes known as active galactic nuclei, AGN. Suddenly grew a lot brighter, glowing nearly 100 times more than normal invisible light. Black hole. Now, an international team of astrophysicists, including scientists from CU Boulder, may have pinpointed that cause of that shift. The magnetic field lines threading through the black hole appear to have flipped upside down. How can they go through if it should somehow swallow everything and, no return? Even light, but causing a rapid but short-lived change in the object's properties. It was as if compasses on Earth suddenly started pointing south instead of north. Yeah, anybody heard about pole shift going on Earth? The findings published May 5th in the Astrophysical Journal could change how scientists look at supermassive black holes, said study co-author Nicholas Skeppy. Normally, we would expect black holes to evolve over millions of years, said Skeppy, a postdoctoral researcher at GILA, a joint research institute between CU Boulder and the National Institute of Standards and Technology. But these objects, which we call changing look AGNs, evolve over very short timescales. Their magnetic fields may be the key to understanding this rapid evolution. How do you get magnetic fields? You need electricity. Okay? Even in space. And it's really well scalable, obviously. An unusual black hole. Bigelman explained that AGNs are born out of some of the most extreme physics in the known universe. These monsters arise when supermassive black holes begin to pull in huge amounts of gas from the galaxies around them. Like water circling a drain, that material will spin faster and faster the closer it gets to the black hole, forming a bright accretion disk. that generates intense and varied radiation that scientists can view from billions of light years away. So really bright blackness. Those accretion disks also give rise to a curious feature. They generate strong magnetic fields that wrap around the central black hole, like Earth's own magnetic fields point in a distinct direction, such as north or south. A black hole's magnetic reversal. There is increasingly evidence from the Event Horizon Telescope and other observations that magnetic fields might play a key role in influencing how gas falls onto black holes, says Dexter, assistant professor of APS. I was once making some pictures. This is what I mean with making a picture. So I took Earth from Google Earth and some measurements. It's not to scale, obviously. I'm not an artist, nor a scientist. I'm just curious. So now we have a geode here. And Thornhill's repellent core, which is bound to charge. Gravity is bound to charge. That's Earth. It's approximately 12,742 kilometers in diameter. So, taking off that, the deepest quake ever recorded, 987 kilometers, we still have 5,877.5 kilometers left to the center. On the other side, our magnetosphere first layer is somewhere here, 3,000 kilometers, which is less than here. And we have a whole layer of the magnetosphere within this. And obviously that's laboratory plasma. And here's the polar vortex, which is the Birkeland current expanding out, spinning in the north and in the south. It is our connection to the sun and through that to the rest of the universe. There are no islands in space. And still this one. Here we have a Birkeland current. In the center there's iron, silica, magnesium. As you go further out, more far out, it's carbon and sulfur, hydrogen, oxygen, nitrogen, and helium. And of course, we have energy exchange into both directions. There is some news by Ben Turner. Mysterious new substance possibly discovered inside Earth's core. And everybody knows Scatterman. Squatterman. Experiment simulation derived geometry. Anthony Peratt. And this one in the middle here, that's a screenshot I took from the La Palma eruption. And here is also a geoid inside the picture really nicely. I am not an architect. What is it? Artist. Actually, that's the same picture here in bigger. You can see. There's a torus. The torus is here, and it's here, and it's here, and it's here. And obviously here also, probably in the center of Earth. But anyway, credit to NASA. There is increasingly evidence from the Event Horizon Telescope and other observations that magnetic fields might play a key role in influences influencing how gas falls onto black holes, which are really bright. Just think about this for yourself. A bright black hole doesn't make really sense, does it? Doesn't. So, they're talking about magnetic fields. There's no magnetic fields without electricity. If you have two magnetic fields, there's an electric current in between, and if you have a huge electric current, you will have magnetic fields around them. Everything is electric. And if a black hole can have a magnetic reversal, then for quite sure Earth has a magnetic reversal as well. Usually it happened 350,000 years in between the reversals, but now it seems the last one has been somewhat 780,000 years ago, so it's time for the next one, and it seems it's going on. And the more it moves, or they move, the North and the South Pole, as closer they get, the more rapid they move. Everybody knows how a magnet works. Just have to mention that. We see the weather patterns are changing. The Atlantic circulation pattern is really messed up. No spring. Let's see how's the summer. There's like many thunderstorms, lightning strikes, and all these kind of things going on. Not only in the Alps region. I guess many farmers, they have difficulties to get their crops going. Getting gasoline for the tractors. Or maybe getting even people to work. If there would be work. But if nothing is growing, what to do? Just have to wait it out. And in the meanwhile, by waiting out things, you can gather your own knowledge about them. I just try to somehow provide you with some things I think they are interesting. Don't believe me a word. Think for yourself. That's the most important thing. If you have something, whatever it is, something which doesn't match up, figure it out why it doesn't. Do it by yourself, for yourself. That's the most important thing. So this also means that you, in one point, come to the point of admitting to yourself that, yeah, I was wrong. I was wrong. I know now better. I gathered some more knowledge. I compared them between. And I figured out that I have been wrong all my life. Change your perspective to things. And yeah, think for yourself. That's really important. I don't know. Maybe that's wrong either. Or two. I don't know. What do I know? That's why trying to get some knowledge about things and figure out in order to somehow get one's mind prepared for things which are coming. They are really interesting, fascinating. Things which haven't been experienced by many people. So I think it's much more interesting when you know what to look at than just not know what you're looking at. Actually, I was just. Does the rabbit hole has a magnetic reversal too? This just popped up in my mind. Magnetic reversal of the rabbit hole. What does that mean? I don't know. I'll leave it here. Thanks.